Okay, I'm coming to you from Lancaster High School on a beautiful Sunday afternoon, making a synthesis video. That's how much I care about you. Okay, so synthesis. Sometimes also called composition. Synthesis is my favorite. So, let's talk about this. General form is usually element plus element. Now, if you have one element and you have a different element, the only thing you can possibly do if you're going to put them together and have a chemical reaction is you're going to get one compound on the product side. You're going to put them together and make one thing. So that's the biggest clue that a reaction is synthesis. You get one compound on the product side. Now, it can be compound plus element. It can be compound plus compound. You're always just going to get one compound on the product side. That's synthesis. Okay, let's talk about some general types. So if you take two or more elements and you combine them to make one compound, now, I know I've done this reaction for you a bazillion times. Here comes bazillion and one. All right, let me turn it so that you can see this. All right, now, magnesium, silvery solid metal. When I heat it, okay, I get a gas and a really bright light. That's energy. And I don't have that silvery solid anymore. Now I have a white powder. Okay, silvery solid, white powder. Turn you back around. Oops, sorry. Okay. Now, so we've got element magnesium, element oxygen. The only thing I can possibly do is put them together and make one thing. Magnesium oxide, which was also a solid. It was a white powder, which was different from the silvery metal and different from the gas. So that shows you when you make a new compound, it's totally different from the reactants. It has all different properties than the reactants. Okay, because of the law of, we gotta make sure this compound is right. Magnesium is +2, oxide is -2, so it is right. They go together 1 to 1. So, because of the law of conservation of mass, we have to balance this. Now I have one magnesium, two oxygens, one oxygen. Okay, I have to have the same number of atoms of each type of element on both sides of the reaction. So I'm going to put a coefficient of 2 in front of the compound because I can't break up the compound. Magnesium oxide is MgO. So that means now my oxygens are good, but I threw off my magnesiums. Easy fix. Put a 2 there, and it's done. Now, magnesium doesn't only react with oxygen in the air. What's another element that's found in air? Nitrogen. Actually, there's more nitrogen in the air than oxygen. So, do you think nitrogen bonds to magnesium as well? Yes, it does. So we're going to write this reaction. Okay, so I have my magnesium, still silvery solid metal, nitrogen, gas in the air. Notice diatomics. Don't forget your diatomics. So if I put those two elements together, the only thing I can possibly do is end up with magnesium nitride, which is also a solid. Now, magnesium has a charge of +2, nitride is -3. So make that formula for me. I'll give you 10 seconds. Okay, done. Got it? Okay, so it should be Mg3N2. Did you get it right? Okay, let's balance this now. 3 magnesiums. Let's just go ahead and put a 3 there because because nitrogen is diatomic, there's 2. There's 2, so it's good. All right, let's move on. Now the next 2, I'm going to I have an asterisk here because I need to show you that it's compound plus compound, compound plus compound. That's why I have the asterisk here, and I'm going to explain this in just a second. These reactions are not that thrilling, so I'm not going to do any demonstrations for you. I'm just going to talk about it. Okay, an acidic compound or non-metal oxide. Remember, non-metals like to make acids because non-metals make anions, negative charge. An acid has that positive hydrogen cation, so they go together nicely. All right, so let's look at this compound plus compound, and it is synthesis. And that's why I have the asterisk here, because it looks like it's double displacement. Compound plus compound is double displacement, right? But if I were to switch the positives and negatives, so the positive is usually first, so if I put this positive with this negative, I would get sulfur and oxygen. That's what I have here. If I put this positive with this negative, I get hydrogen and oxygen together. That's what I already have. So if it looks like it's double displacement and you try to put the positives with the negatives and you end up with the same thing, that's your clue that it is synthesis. Okay, let me get rid of those. So that means I'm going to put them together and make one thing. So I know I'm going to make an acid. So I'm going to put my hydrogen there first, because remember, acids usually have hydrogen in the front. And then to figure out what acid it is, look at your nonmetal oxide here. Bump the oxygen up by 1 and write that down. SO4. That's sulfate. Sulfate has a -2 charge. Hydrogen is +1. I still have to write my formula of the compound. -2 + 1. So I make sulfuric acid. And that's going to be aqueous. Okay? Questions? You can't ask me. All right, we have to balance it. Well, 2 hydrogens, 2 hydrogens, 1 sulfur, 1 sulfur, 3, 4 oxygens, 4 oxygens. Balanced. Let's go on. Okay, a basic compound or metal oxide combines with water to make a base. Remember, metal oxides, metals, are cations, so they like to bond with hydroxide, which makes a base. The polyatomic hydroxide makes it a base, just like up here. Hydrogen ions make something an acid. So metals tend to be cations. Hydroxide is an anion, so they go together. Now, once again, look at, I have 2 compounds, so it looks like compound plus compound looks like double displacement. But once again, if I try to switch the partners, I'd get sodium plus oxygen, hydrogen plus oxygen. I'd get the same thing. That's your clue that it is synthesis. Okay, so since I see I have a metal oxide in water, then I just have to know I'm just going to make it a base. So what makes something a base? Hydroxide. What do I put with it? My metal. Sodium is +1, hydroxide is -1, so it goes together 1 to 1. Oops. And that one is going to be aqueous because sodium is in column 1, remember? All right, so now we have to balance this one. 2 sodiums, 2 sodiums, 2 hydrogens, 2 hydrogens, 2 oxygens, 1, 2, 2 oxygens. It's balanced. Okay, now, the last one. So, element plus oxygen. So I'm going to make an oxide here. So I have iron here twice because iron can make 2 different compounds with oxygen. Iron can make iron 2 oxide. Iron can make iron 3 oxide. Okay, iron 2 means it's +2, oxide's -2, so that's my compound. Iron 3 oxide would mean the iron has a charge of +3, oxide is -2, crisscross it. That one's also a solid. Okay, let's balance them. 1 iron, 1 oxygen. Oop, gotta change that. So my oxygens are good, and my irons are good, balanced. Okay, now I see I have 3 oxygens here, 2 here. So I have to put a 2 here and a 3 here to balance my oxygens, which means now I have 4 irons. Done. Okay, synthesis.